Hello, everyone, and welcome to our live coverage of NASA's Traces mission launch from West Coast, that is from Pad Space Launch Complex 4 East at Vandenberg Space Force Base in California. If this is your first time here joining us, hi, my name is Dipto Maitra, your friend and the host performing the commentary for today's mission launch, and you are watching AstroYonder live.
Roger, 0G, and I feel fine. Capsule is turning around.
Houston, we see a nominal MECO. Welcome to space.
Hope you all are doing fine and excited for the upcoming launch. As always, we are so grateful to have you here with us, and thanks for tuning in. We are super excited bringing you the coverage of SpaceX's 518th overall launch and the 90th Falcon 9 launch of this year. Today's launch marks the 31st one from Vandenberg for SpaceX as they continue building their incredible launch cadence for this year. SpaceX recently hit a huge milestone with the commercial GTO-1 mission, reaching 500th successful mission by Falcon 9 itself. Just last month, they had another huge milestone on June 12th. Starlink launch from Vandenberg here, marking their 500th overall successful mission. And just a day later, with the June 13th Cape Canaveral launch, they completed the first generation of their direct-to-cell constellation, back-to-back incredible milestone for SpaceX. Now, just a reminder, we will break down each payload in details as much as possible based on our extensive research. So hang in there with us. I know it's early in the stream to ask, but consider giving this stream a like. It really helps us reach more space enthusiasts like you joining us right now. We are currently standing by for a Falcon 9 liftoff at 11:13 a.m. Pacific time, 2:13 p.m. Eastern time from California, heading on a southwest trajectory for NASA's Traces mission, carrying a batch of twin tracer satellite and 5 other payloads to Sun-synchronous orbit. Now, before we ignite the engine on today's mission details, we just want to thank you from all of us at AstroYonder team, along with our incredible moderators, for joining us on this launch ride. We are truly fueled up by your presence and support that inspires us to work more hard and to meet your expectations. A big thanks to our amazing YouTube community for the encouragement that keeps our mission flying. Heartfelt gratitude for helping us to bring you deep dive launch coverages loaded with all the stats and insights. We are truly glad to have you on this journey as we count down to the liftoff together. We would really appreciate it if you guys could join the chat and let us know where you are joining from. Also, feel free to share any questions, suggestions, or opinion with us that will make us to improve our streams and to meet your expectations as well. So please don't be shy, just bring them on. We would love to hear from you guys. Now, just a heads up, it's me only managing the launch coverages on my own. So if by chance we face any technical issues, please bear with me and be tuned in. There is absolutely nothing to worry about and you won't miss anything. I will do my best to guide you through the Falcon 9 rocket launch happening in approximately 1 hour, 8 minutes from now. SpaceX will be starting their webcast 15 minutes prior to the liftoff. And we started a bit earlier so that we can give you more insight and the details about the missions and about the payloads as well. Once again, just a reminder, SpaceX is currently targeting a liftoff time of Falcon 9 from Vandenberg Space Force Base at 11:13 a.m. Pacific Time, 2:13 p.m. Eastern Time on Wednesday, July 23rd of 2025. Today we have just 57 minutes of launch window before it closes out at 12:10 p.m. Pacific Time, 3:10 p.m. Eastern Time. Now let's get into the mission details. As we don't receive launch weather forecast for Vandenberg flights from 45th Weather Squadron, but reports suggest so far that the weather is looking good for today's Falcon 9 launch opportunity and the range is ready to support. Weather officials keeping a keen eye on weather for any probability of launch weather constraints and range violations. The forecast calls for a temperature of 21 degrees Celsius, scattered clouds with 46% cloud cover and a wind speed of 10 miles per hour. Yesterday, we saw a rare last-minute scrub announced by SpaceX's launch director for this mission, which was caused by a regional power outage in Santa Barbara that disrupted telecommunication at the Los Angeles Air Route Traffic Control Center, a critical hub managing Pacific air traffic. This reflects the FAA's stringent safety protocols to ensure public safety. But anyways, we hope that today they are able to launch on time and not have to push off too far. Now, before moving on to the payload details, would like to welcome Angry Bird showing on the chat, one of the moderators joining us here. I hope you are doing well, Angry Bird. Thanks for tuning in, and I guess you will be enjoying the stream and I can meet your expectations. So now let's take a look at today's payload details for the Tracers mission and the companions hitching a ride on this SpaceX Falcon 9 rocket. Now, before discussing about the payload details, just a reminder, if SpaceX streams through payload deployment after first stage landing, we will cover them in more details later during the course phase of the second stage. But for now, here is a comprehensive overview of the payloads. So first up is NASA's Tracers, or Tandem Reconnection and Cusp Electrodynamics Reconnaissance Satellite, which are all about studying magnetic reconnection where the sun's magnetic field interact with Earth's magnetosphere, causing field lines to snap and reconnect, which releases high energy that drives space weather events like auroras, which we see most of the time and we get amazed by that, or satellite disrupting geomagnetic storms, or even it can knock out the power grids. Tracers will focus on the polar cusps, the funnel-shaped region that you can see right now on your screen, near the north and south pole, where solar wind particles sneak into Earth's atmosphere. It's two identical satellites, T1, also denoted as T1 and T2, each equipped with 6 instruments to measure electric and magnetic fields, as well as the particles involved in reconnection events. These instruments were developed by powerhouse team including the University of Iowa, Southwest Research Institute, UCLA, and UC Berkeley. The satellites built by Millennium Space Systems, which is a Boeing subsidiary, and these satellites, the Tracer satellites, will be operated by the University of Iowa, led by principal investigator David Miles, with oversights from NASA's Heliospace Heliophysics Explorers Program Office at Goddard Space Flight Center. This tandem setup allows them to capture sequential data as they pass through the northern polar cusp multiple times daily, giving scientists a dynamic view of how reconnection unfolds. The University of Iowa lead principal investigator David Miles operates the mission with NASA's Heliophysics Explorers Program Office at Goddard Space Flight Center overseeing it. Each satellite has a launch mass not exceeding 200 kg and is passively spin stabilized at a nominal rate of 10 rpm for magnetic and electrostatic cleanliness. They operate in a sun-synchronous orbit at approximately 590 kilometers. Please excuse me, there are some power fluctuations going on. So I was saying they will operate in a sun-synchronous orbit at approximately 590 kilometers. Which is equivalent to 367 miles altitude with a separation of 75 to 900 kilometers, trailing each other by 10 to 120 seconds. Each satellite carries 6 instruments, namely analyzer for cusp electrons, also in short it is known as ACE, analyzer for cusp ion, in short it's known as ACI, DC magnetometer, in short MAG, search coil magnetometer, also known as MSC in short, electric field instrument, which is in short known as EFI, and lastly the sixth one is the magnetometers for innovation and capability, also known as MAGIC. These satellites are powered by solar panels, and this mission is expected to last a duration of at least 12 months. Traces falls under NASA's Small Explorers Program, which is also known as SMEX in short, which funds high-impact, cost-effective heliophysics missions. The goal is to deepen our understanding of space weather, protecting everything from satellites to astronauts by predicting and mitigating solar-driven disruption. So that's all about the star of the show for today's mission. That's the Traces twin satellites. Now, next up, we have Athena EPIC, or Economical Payload Integration Cost, a small satellite with a big vision. This payload is all about revolutionizing how we get remote sensing instruments into orbit, making it faster, cheaper, and more flexible. Now, think of it as a modular spacecraft like a LEGO set for space, where multiple instruments can share resources on a single platform. NovaWorks, a space startup, developed the spacecraft with NASA's Langley Research Center leading the design and integration with funding from NOAA, that is NOAA, and the US Space Force's Space System Command, also known as SSC. SEOPS, which is SEOPS, a leader in a rideshare mission services, handles the capacity integration and mission management and operations for this payload. Athena EPIC is a pathfinder for NovaWorks' innovative SensorCraft architecture. This approach could slash cost and timelines for deploying Earth Earth observing techs, opening a door for more government and commercial missions. Weighing in at approximately 110 kilometers, Athena EPIC is part of Department of Defense's Space Test Program, carrying a Department of Defense experiment to test this new architecture. The satellite's objective is to demonstrate how configurable platform can support a rapid response remote sensing missions, potentially transforming how agencies like NASA, NOAA, that is NOAA, and the Space Force collaborate. It's flying under NASA's Venture Class Acquisition of Dedicated and Rideshare Program, also known as VADR in short, which focuses on affordable launch opportunities for small sats. It is also the fifth of 6 spacecraft under the United States Space Force's Rideshare 2024 Blaze contract with SEOPS, that is SEOPS. Now, if successful, Athena EPIC could set a new standard for cost-effective space missions. Now, moving on to the next payload. So now we have the relativistic electron atmospheric loss CubeSat, also known as REAL in short. This little powerhouse is tackling a big problem, that is high energy particles in Earth's Van Allen radiation belts. I guess those who saw the previous Polaris Dawn mission, they are familiar with this Van Allen radiation belts term. But today I'm not discussing about that. So these belts, I'm just giving a short overview of this Van Allen radiation belt. This belt's filled with charged particles trapped by Earth's magnetic field, which can wreak havoc on satellite electronics. REAL's mission is to study how relativistic electrons get scattered into the atmosphere where they lose energy and dissipate. By understanding this natural process, scientists hope to develop methods to artificially clear out these particles, protecting satellites and critical ground systems from radiation damage. Developed by Dartmouth College under NASA's CubeSat launch initiative, REAL carries an instrument sensitive to high energy protons and electrons. Dartmouth College operates the CubeSats with data analysis supported by NASA, whereas Maverick Space Systems, a California-based launch integrator, supports the mission's deployment. The satellites builds on technology from Montana State University IT Spin's CubeSat with upgrades for enhanced particle detection. This also marks New Hampshire's first CubeSat launch under this initiative. Once in orbit at about 367 miles, REAL will collect data to characterize particle loss, contributing to strategies for safeguarding space infrastructure. Similar to like Athena, EPIC, REAL is part of NASA's VADR program, leveraging rideshare opportunities to get cutting-edge science into orbit affordably. So next we have is the BARD, also known as Polylingual Experimental Terminal, in short PExT, PExT. Now, BARD is developed by York Space Systems, a NASA-funded technology demonstration focused on improving spacecraft communication. Now, in a layman term, I'm saying that imagine satellites hopping between different communication networks like your phone switches between cell towers. Bard is testing a terminal that operates across a wide frequency range between 17.7 GHz to 31 GHz, which allows it to speak the languages of various commercial and government Ka band networks. This polylingual capability could enhance connectivity for missions needing real-time data transfer from space weather monitoring to deep space exploration. Managed by NASA's Space Communications and Navigation, also known as SCAN program in short, BARD is a collaboration with Johns Hopkins University Applied Physics Laboratory. With a $20 million life cycle cost over 5 years, the initial demonstration will run for 6 to 9 months. The objective of this satellite BARD is to prove that spacecraft can roam seamlessly between networks, improving reliability and flexibility. Like Athena EPIC and REAL, BARD is also a part of NASA's VADR program, taking advantage of this rideshare to test game-changing technology. Now coming to the last two payloads on board today's mission. Next we have the LIDE or LIDE, LIDE, also known as Direct Access Live Demonstration, which is a 12-unit CubeSat developed by Taiwan International, now part of Terran Orbital, which is a Lockheed Martin company. LIDE is a European Space Agency mission under its Connectivity and Secure Communication Office, and it's all about testing advanced satellite communication technology. Specifically, LIDE carries a bidirectional Ka and Ka band radio frequency transponder designed to enable direct access tests with ground terminals compliant with 3GPP non-terrestrial network standard. This is a step towards providing 5G broadband access from space, particularly for rural and suburban areas in collaboration with the REMI mission, which focuses on feasibility studies for 5G connectivity. LIDE's active attitude determination and control system ensures optimal satellite orientation for enhanced signal reception. And this satellite is operated by European Space Agency. The satellite aims to validate this transponder technology, which could enable seamless high-speed telecommunication links for future missions. As a rideshare payload on Tracer's mission, LIDE benefits from SpaceX's Falcon 9 and NASA's rideshare framework, demonstrating how international partnership can push boundaries of space-based connectivity. Now, finally, we have Skycraft 4, a set of 5 Australian satellites designed to enhance air traffic management, which is also known as ATM in short, from space. These satellites, developed by Skycraft, an Australian aerospace company, are part of growing constellation and aimed at providing real-time communication between air traffic controllers and pilots. Using VHF frequencies and automatic dependent surveillance broadcast technology, Skycraft 4 will help track aircraft and enable direct communication, filling gaps in traditional ground-based air traffic control system. This is especially critical over oceans and remote regions where coverage is spotty, improving safety and efficiency for global aviation. The Skycraft 4 satellites, collectively weighing around 260 kilograms, includes a deployment tug, that is the Skycraft 1, that separates from the Falcon 9's upper stage and releases 4 additional satellites. Skycraft, in collaboration with Air Services Australia, operates these satellites, which are testing regulatory updates needed to integrate space-based air traffic management services. The mission's objective is to validate this innovative approach, paving the way for a fully operational constellation. While Skycraft 4 is a commercial payload, it is hitching a ride on this NASA-led mission through SpaceX's rideshare program, showcasing the power of international collaboration in space. So that's all about the payloads on board today. Unfortunately, for some of the payload, we couldn't manage to have the images because they are not publicly available. So my sincere apologies for that. And hopefully all this explanation about the payload on board today gave you a bit more insight. Well, one thing I forgot to say, this Skycraft 4 will deploy 4 satellites starting from Skycraft 4A to 4D. Although we will be seeing, if SpaceX will be showing the payload deployment, we will be seeing the Skycraft 1, the deployment Turk, to be getting deployed, which will be having the 4 additional satellites inside it, which will be releasing later time. Now, if you feel we are adding value to your viewing experience, please consider giving this stream a like. It really helps this stream to reach out to a broader audience and also to grow our amazing YouTube community with amazing space enthusiasts like you joining us right now. Would be super grateful for that. Now, let's take a look at the flight record for the booster supporting today's mission. Now, before moving on, once again, just a reminder about the payload description I provided just a couple of minutes ago. It was an overview. We will dive deep. If SpaceX will stream the whole deployment sequence, we will have ample of time during the course phase of the second phase with the payload on board. So during that time, we will be diving into the details of each payload in more technical way. So let's move on and take a look at the flight record for the booster supporting the NASA's TRACERS mission. The booster with tail number 1081 supporting today's mission, which is a mid-age booster, you can say, with 15 previous flights in its record, including 7 non-Starlink missions like SpaceX's Crew 7 for NASA under Commercial Crew Program, which marked the 11th overall crewed orbital flight of a Crew Dragon spacecraft. Next up is the CRS-29. That is the Commercial Resupply Services mission to the International Space Station, which marked the 9th flight for SpaceX under NASA's CRS Phase 2 contract. Next up is NASA's PACE mission, which stands for Plankton Aerosol Cloud Ocean Ecosystem, which is a NASA Earth observing satellite mission. And 2 rideshare missions supported by this booster transported 10, which launched 53 satellites, and another one recently transported 13. European Space Agency's EarthCare mission is also being supported by this booster, which is a joint European-Japanese satellite under European Space Agency's Earth Explorer program. And the last non-Starlink mission supported by this booster was the NROL-186 mission for National Reconnaissance Office. And additionally, this booster supported 8 Starlink missions. Now awaiting its 16th flight, just approximately 43 minutes away from now. The last mission supported by today's booster was Starlink 15-6 on June 12th of this year. The booster's turnaround time as of today is 41 days. And worth mentioning, today's mission will be the 12th consecutive launch of this booster from Pad Space Launch Complex 4 East. Also today, the booster will have its 7th ground landing to date. Previously, it made 8 landings on, of course, I Still Love You drone ship at the west coast, and one time on a shortfall of Tabitha's drone ship at the east coast in its record. So that's all about the flight history for the booster supporting today's mission with tail number 1081. Now let's have a look at the bar graph showing the number of Falcon 9 launches each year. Before this upcoming launch, SpaceX completed its 89th Falcon 9 launch for this year with SES-03B M-Power mission, which launched from Cape Canaveral on July 22nd, 2025, yesterday, obscuring the number of annual launches made till year 2022. Right now, SpaceX is now having 28 more than launches made in the year 2022. Now, with the upcoming launch for the Tracers mission, the bar graph shows 90 number of Falcon 9 launches for 2025. As of now, SpaceX is less than halfway to reach the number of launches made in year 2023 and 2024. And with today's launch, SpaceX is now only 6 behind 2023's total and 42 short of 2024. SpaceX is once again aiming for another record-breaking year with around 170 to 180 launches, surpassing last year's highest annual launch count of 134 launches in total, including 2 Falcon Heavy missions. So that's an ambitious target. Let's hope they pull it off. Now, once again, just a request, if this stream fuels your love for space, give this stream a like. It's kind of fine-tuning the trajectory of our mission to build a community with amazing space enthusiasts like you. And don't forget to subscribe and turn on the notification so that you won't miss a single launch update. Here at AstroYonder, we believe we will build the ultimate constellation of space enthusiasts. We would be super grateful for your kind support. Now, please allow us a couple of seconds to check whether the launch is on time or not and to stay updated. As of now, SpaceX is sticking with their current liftoff time of 11:13 a.m. Pacific time. So no worries about that. So let's move on and let's know a little bit more about today's mission. I will be skipping the pre-launch timeline since it's a typical Falcon 9 launch with absolutely no alteration or deviation in any of the pre-launch events. You can track the pre-launch timeline updating live on the upper left-hand side of your screen. However, there's one point I would like to highlight just for your quick knowledge and which you might be already aware of, that the strong back reclining process at Vandenberg differs from that at Cape Canaveral and Kennedy Space Center. Here at Cape Canaveral and Kennedy Space Center, we recline the strong back about 1.5 degrees away from the Falcon 9. Excuse me, what I say, I got confused a little bit. Just let me once again repeat it. Here at Vandenberg, we recline the strong back about 13 degrees, whereas at Cape Canaveral and Kennedy Space Center, we recline the strong back about 1.5 degrees away from the Falcon 9. So that's the only thing which is different in today's pre-launch schedule, as this is a Vandenberg flight. Now, just a reminder, SpaceX is currently targeting a liftoff time of Falcon 9 from Vandenberg Space Force Base at 11:13 a.m. Pacific Time, 2:13 p.m. Eastern Time on Wednesday, that is July 23rd of 2025. Before moving any further, would like to welcome Mulugu Satya Narayana for joining us. Thanks, Satya Narayana, for tuning in, and I hope you'll be enjoying the stream with us as we move ahead with the stream. Now, let's go ahead and briefly step through the trajectory for today's Starlink mission. Falcon 9 leaving the pad from Space Launch Complex 4 East from Vandenberg Space Force Base with NASA tracers and other spacecraft on board for a somewhat southwesterly trajectory to low Earth orbit, indicated by that green line on your screen. The red line you see indicates where Falcon 9 first stage will land after stage separation, just a little later, leaving California's coast. And today, this is going to be a ground landing, which means it is a return to launch site operation, also known as RTLS in short. For today, it's landing zone 4, SpaceX's landing site here on the west coast. This will be the SpaceX's 91st overall land landing and 27th on landing zone 4 to date. Now, some recovery specifics for you. The estimated fairing recovery approximately 500 kilometers downrange, and the second stage debris reentry will be in the South Atlantic Ocean or Indian Ocean on its second orbit. Now, here is a point just to highlight that the trajectory for today's mission is somewhat similar to the rideshare missions for aiming for Sun-synchronous orbit. Previously, we saw that in other rideshare programs. Now, about the fairing recovery, the two halves of the payload fairing will be recovered farther, approximately 500 kilometers downrange from where the first stage lands on landing zone 4. After, they will smoothly splash down with the guidance of parachutes. SpaceX will utilize a recovery vessel to retrieve them from Pacific waters. And we know that the fairing halves are manufactured by SpaceX in-house with a total cost of two halves is nearly $6 million. Quite obvious that SpaceX aims to recover the fairings for repetitive use, which also mirrors their approach with rocket boosters, upholding the motto of reusability and sustainability. Now on your screen, you can see how a fairing recovery operation looks like. Although the recovery vessel on your screen is dark, performing the recovery operations, but today's supporting recovery vessel is Go Beyond here at the Pacific. Other recovery vessels at the East Coast, Bob, Doug, and Go Cosmos, are waiting for their next assignment. Well, Angry Bird, the live will be starting approximately 16 minutes from now. We are just getting close to the webcast, so let's just quickly get done with the stats we have to share with you guys. If you feel we are adding value to your viewing experience, please consider giving this stream a like. It's kind of a fuel for YouTube's algorithm rocket, bringing in more space lovers, helping rocket fans to discover this stream out. It also helps us to grow our community of amazing space enthusiasts like you. Also consider about smashing the subscribe button and turning on the bell notification, as we are burning the all-day propellant to bring you detailed streams packed with stats and insights. Your support would really inspire us and to keep up with our hard work to meet your expectations. Now, coming to some of the stats for today's mission. Well, I guess Alex Lammers, I think the timeline is right, or let me check also. No, the timeline is correct. So there is absolutely no issues. You can see the timeline, currently updating live. And thanks, Alex Lammers, for tuning in. I hope you will be enjoying the stream. Now we are getting close, approximately 14 minutes away from the webcast to begin. So let's just quickly get done with the stats for today's mission launch. Today's launch marks the 518 SpaceX's overall launch and the 26th dedicated non-starting mission launch of this year. Well, Alex, let me see if SpaceX gave any updates. According to the liftoff time, I set my timer here, but still let me check if SpaceX gave any confirmation for the prop load. As of now, SpaceX didn't provide any update for the prop load. I guess they are on time because we are getting close to the webcast and they didn't shifted or adjusted their webcast time as well as no updates on the their website. So I guess they are on time. So coming back to the stats, this is going to be the 505th Falcon 9 launch to date. 16th flight of this particular Falcon 9 booster supporting today's mission, with tail number 1081 being in action after 41 days. By that I mean the booster's turnaround time is 41 days. Today's mission marks the 90th Falcon 9 launch and SpaceX's 93rd overall launch of 2025, including 3 Starship flights this year. This will be the 445th Falcon booster reflight to date. That is the launch of a booster that has flown at least once before. 137th orbital launch for SpaceX, launching from Space Launch Complex 4 East with this mission, which also marks the 204th overall orbital launch from Sleep 4 East. Well, we are now just 11 launches away to reach 100th launch by SpaceX for this year, by just counting the Falcon 9 launches alone, excluding the Starship launches. And also, I guess we are about to witness the 30th flight of the booster with tail number 1067 in an upcoming recent Falcon 9 launch. So another 2 big milestones waiting around the corner. Now moving on to some reusability statistics. This flight marks the 429th reflight of a Falcon 9 booster to date. This will be the 5th landing on landing zone 4 this year, which marks 11th ground landing of the year and the 27th overall landing on landing zone 4. 16th landing of the first stage booster with tail number 1081 supporting this mission. And with this booster's landing, SpaceX racks up its 91st ground landing in total, the 459th Falcon 9 overall landing, and the 478 landing across all boosters to date. Now, just a quick note, we are excluding the landing failure on Just Read the Instructions drone ship during this year's Starlink 12-20 mission, as it was a partial success. So there's a 1 landing difference in Falcon 9 and overall stats compared to what SpaceX lists on their website. So please don't get confused about that. Now, speaking of land landings, let's look into the stats for land landings prior to today's mission. The most recent ground landings performed was at landing zone 1 for Axiom mission 4. which marked the 52nd successful landing on the landing zone 1 to date. Once again, just a reminder, please note that this landing zone stats right now on your screen are prior to today's launch. Once again, please don't be confused with these stats on your screen right now. Now, although today's mission involves a ground landing at landing zone 4 and does not use a drone ship, but here are some of the drone ship stats prior to this mission for your reference. Now moving on, let's have a look into some key stats for SpaceX launches in this year. Specifically this year, including today's mission. Well, would like to extend my heartfelt gratitude to Angry Bird, our moderator, for backing up. Thanks, Angry Bird, for those kind words. So moving on with the stats. With today's mission, SpaceX will be having its 93rd launch of this year, and out of those, 64 are Starlink missions, 26 are non-Starlink missions for commercial and government organization, including this one, today's launch, and 3 Starship launches. 85 of these missions using a reuse booster, including today's mission. Now, if we look into the geographical distribution, we get SpaceX is having 59 launches from the East Coast, 16 from Launch Complex 39A, that is Kennedy Space Center, and 43 from Space Launch Complex 40, that is from Cape Canaveral Space Force Station. On the West Coast, they will be having 31 launches with today's mission, that is from Space Launch Complex 4 East at Vandenberg Space Force Base. As of now, 3 launches from Gulf Coast at Starbase in Texas, and 2 Super Heavy booster catches with Starship's 7th and 8th test flights. On Flight 9, we know no Super Heavy booster catch was attempted. Now, according to some current speculations going on, guess the Starship Flight 10 will be in the second week of August, if everything goes as planned. Now, for landings, they will be nailing it today for the 88th time this year. As of now, most of the landings are on drone ship like every other year, with 77 landings. And among the drone ships, a shortfall of Gravitas is leading with 27 landings made on it. For ground landings, they will be pulling off 11 of them today, where landing zone 4 will witness its 5th landing, including today's mission. Now, in order to return to launch site, that is the RTLS capabilities, which we will be seeing in today's mission as well. SpaceX, as SpaceX's lease for landing zone 1 and 2 expires July this month, SpaceX is now working on adding a landing pad at the East Coast. And I guess it will be a single landing zone, unlike now, where we have 2 of them. Now we are just 6 minutes away from the webcast to begin. Let me just quickly check whether they are sticking with the liftoff time or not. I guess SpaceX adjusted their webcast time, pushing it 2 minutes back. but the liftoff time is currently the same, that is 11:13 a.m. Pacific time. So it's just an adjustment with the broadcast stream. So no worries about the liftoff time. They are sticking with their current liftoff time. Now, prior to today's launch, the stats on your screen are: the success rate for ground landing is 98.90%. For drone ship landing, it is 96.99%, and the overall landing success rate is 97.35%. The landing success rate for this year dropped to 98.86% due to the failure of booster with tail number 1086 to land successfully on just with the instructions drone ship during Starlink 12-20 mission, which is considered as a partial success, but SpaceX, I don't know why they are considering it is a complete success. That's why I mentioned that we are having a difference of 1 for the Falcon 9 landing and the overall landing stats, which is listed on the SpaceX's website. The longest stretch of the successful mission in a row prior to the last mission failure, that is Starlink 9-3 mission, is 334 back-to-back successful missions, that is from Iridium 1 to CubeSat 6A. And today's mission is the 154th launch since last mission failure, that is the Starlink 9-3 mission. Most launches in a calendar quarter to date is 46 launches, including 1 Starship launch in the second quarter of 2025, which was 42 launches, including 2 Starship launches in the fourth quarter of 2024. And most launches in a calendar month is 17 launches in November 2024 and May 2025, including 1 Starship launch each. Once again, the current stats on your screen are prior to today's launch. These stats are also prior to today's launch, and what we have is 153 successful launches since last mission failure with Starlink 9-3 mission, 63 successful landings since last landing failure with Starlink 12-20, booster with tail number 1067 having highest number of flights and successful landings, that is 29 times, and with the previous Starlink mission launch of group 10-25. 364 missions with at least 1 reuse fairings, and approximately 694 number of fairing halves were reused prior to today's launch, with a fairing half reused to reach 32 times. Well, this fairing half reuse counts are approximate, so please don't take it as granted. It's just an approximate figure. We are just 4 minutes away from the webcast. Let me just check once again if there is any more adjustment. No, as of now, there is no more adjustment. Now, moving on to this year's orbital launches, including today's mission. With this 157th orbital launch of this year, United States is leading with 105 launches with 66.9%, followed by China with 37 launches, Russia with 8 launches, 2 launches each by Japan and India, and Europe with 3 launches. Australia is just about to debut with the launch of Ares rocket, scheduled no earlier than July 27th, which got scrubbed on its initial attempt due to some fairing half issues. Well, we got an update from SpaceX's end that currently all systems are looking good and weather is favorable for the liftoff of NASA's TRACES mission at 11:13 p.m. AM Pacific time. and 2:13 p.m. Eastern time. But they didn't provided any confirmation for the LOX load. But as the timeline suggests, I think it's underway. Now, moving on to this year's orbital launches by rocket variation, which includes today's launch as well. Falcon 9 is currently gearing up for its 90th launch. I will try to provide a more breakdown, like detailed breakdown of this pie chart in the upcoming streams. Currently, uh, you can see on the very bottom there are others, legend with 23 number of rockets. That includes various rockets which are not categorized otherwise. So I will try to make it in a good way so that you can know each of the rocket, how many times they got launched this year. Now, while you check out this pie chart, let me see if the stream is rolling or not, as it's time for the webcast to begin. Well, Angry Bird is not detailed actually. Those 23 number of them, anyone can ask for that, how which rockets are included in them. So, you know, I maintain those stats in the Excel sheet, so I will be just exporting them here. Nothing of a big issue or something. So currently, SpaceX start rolling their stream absolutely on time. As of now, they are playing some pre-launch tune. There is nothing you are missing. So please provide me a couple of seconds to set things up for you guys. So there we go. We have the stream online. As I mentioned, SpaceX has some pre-launch tunes going on. I will patch in the mission audio feed once it drops. Once again, just a humble request to all of you joining us right now. Adding value to your viewing experience is our top priority here at AstroYonder. If you felt we somewhat achieved that, please consider liking this stream. It really helps others to find this stream. Also consider subscribing to our channel as we work hard to bring you streams packed with stats, details, and insight. We would be incredibly grateful for your kind support. Now, during our pre-launch discussion, we discussed about the payloads on board for today's mission in an overview. Now, once again, I'm just reminding you guys that if some if SpaceX will be having, they will be showing us the full deployment sequence. So we will be having some time, enough time during the course phase. At that time, we will be discussing the payload details more in a technical way. So let's just wait for the live feed coming from SpaceX's end for the Falcon 9, waiting for its liftoff for the NASA's Traces mission. Today on board, it is having 7 payloads. So there we go. We have the live stream rolling. Also worth mentioning that at the end of this month, I guess on 31st, of July, we will be having the Crew 11 launch for their destination to the orbital outpost, and that will be the last crewed spaceflight from SpaceX's end this year. I know that's a controversial thing, which Elon previously said that he will be decommissioning the Dragon. I think it is nothing related to that. It's just the last crewed flight for this year for SpaceX.
Good morning, everyone. On your screen is a live view of our Falcon 9 rocket as it awaits its 11:13 a.m. Pacific Time launch from Space Launch Complex 4 East at Vandenberg Space Force Base in California. My name is Zachary Lupin, and I'm an avionics supply chain engineer here at SpaceX.
And I'm Amanda Years, a ground systems engineer, and we're joining you from Hawthorne, California.
Welcome again to our webcast coverage for the launch of NASA's Tracers mission. Now, if you were with us yesterday, you'll know that we stood down due to airspace concerns. But we're back today for our second attempt with the good news that the range is currently green and ready to support. Now, TRACER stands for Tandem Reconnection and Cusp Electrodynamics Reconnaissance Satellites. TRACERS is a tandem satellite mission that will study how the solar wind interacts with Earth's magnetosphere, which is the region around Earth dominated by our planet's magnetic field. And this is becoming more important because space weather events can affect our power grids and communication satellites and create potentially hazardous conditions for astronauts.
We'll have more information about this mission in just a minute. In addition to tracers, we have 5 payloads on board today. These include the Polylingual Experimental Terminal, a NASA partnership with the Johns Hopkins University Applied Physics Laboratory that is testing an advanced space communications technology. Also along for the ride is Athena EPIC, a small satellite mission serving as a pilot opportunity to pathfind an innovative, scalable space vehicle design to support future missions.
We also have a payload called REAL from Dartmouth and Johns Hopkins, which will investigate how the high-energy particles in the Van Allen radiation belts are scattered into Earth's atmosphere. We also have LIDE from the European Space Agency, which aims to demonstrate direct 5G broadband connectivity from LEO to small ground terminals. And finally, there's also a demonstration mission called Skycraft, which is a satellite that aims to provide seamless communication between pilots and air traffic controllers using the same VHF radios they use near an airport, but in this case, anywhere on the Earth.
For now, at just over T-minus 11 minutes from launch, both the vehicle and range are green. Weather currently has a 0% probability of violation. If for any reason we have to call a hold on today's launch, a backup opportunity is available tomorrow at 11:13 a.m. Pacific Time.
So that's a good news that today the weather is having absolutely no issues, and the most importantly, the range is green. Also, SpaceX didn't mention that they have a backup opportunity for tomorrow's launch on their website, but on the webcast we heard that. So that's a good thing. But let's hope that there will be no hold for today's launch.
The twin satellites will measure magnetic reconnection a record-breaking 3,000 times, helping scientists better understand and prepare for the effects of the sun on Earth.
Here's a brief overview of the Tracers mission.
Well, I'm sorry that I have to mute the audio on the stream currently right now because these videos right now are having some audio tracks which are copyrighted and we can't play them on our stream due to copyright issues. Although I did mention everything in our pre-launch discussion, so I think you won't be missing if you joined us from earlier anything. They are showing about the Tracers mission, that what it is. As you just heard from the webcast also, that it stands for Tandem Reconnection and Cusp Electrodynamics Reconnaissance Satellite, which are a twin satellite and are all about studying magnetic reconnection. It is where the sun's magnetic field interacts with the Earth's magnetosphere. causing field lines to snap and reconnect, which releases energy that drives the space weather event like auroras or the satellite disrupting geomagnetic storms, or even which can knock out the power grids here on Earth. Basically, all the space weather is being driven by the sun and its activity. So tracers will be once again a sun observation, that is, you can say a heliophysics program it is under. And also it will work alongside the recently launched NASA's Punch mission, and it will also work alongside the EASY mission. Altogether, they will provide a clear picture for the scientists that will help us to understand about this electrodynamic electrodynamic issues that cause some problems with the geomagnetic storms and with the power grids, as well as the satellites on orbit and astronauts in space. Tracers will focus on polar curves, funnel-shaped regions near the north and south poles where solar wind particles sneak into Earth's atmosphere. So currently we are getting some spectacular views of the Falcon 9. It's quite sunny out there, and I guess it's a little bit hot there as well. We are having absolutely no issues with the weather, and the good news is that, like yesterday, we don't have any concerns with the range today, and the range is green. And currently you are seeing the landing zone 4. Fortunately, this will be residing, and as I mentioned, that the landing zone 1 and landing zone 2 release for SpaceX will expire this month. So they are currently working for adding a landing pad at the East Coast, and it will be a single landing zone instead of 2, which we are having right now. Now let's have the mission audio feed back on our stream.
The fairings will be pulled from the ocean and prepped to fly again on future missions. So much of what makes Falcon 9 remarkable happens in flight. We have stages separating, the first stage landing itself back on land or on a drone ship in the middle of the ocean, fairings parachuting back, all ready for another flight to space. Every part of Falcon 9 is part of a larger design that comes together to do one thing.
About what you are saying, Angry Bird, that what these lines are from their side, I'm not understanding. If you can elaborate a little bit, it will be helpful for me to understand.
The Rector, or TE, will begin to retract away from Falcon 9. The TE is that large truss structure you see standing next to the rocket. It's hinged at the base and connected to the launch mount beneath the first stage.
Now coming up, the clamp arms around the second stage will first open away from the vehicle, and then the TE will pivot backwards, slowly swinging away from the rocket. It will achieve full recline by the T-3 minute and 40-second mark. Now throughout this process, you may also hear the TE referred to as the strong back. This is the same structure, just a different name.
And the TE
pressing for strong back retract.
So we got the call out that the strong tanks are pressurizing for the strong back retract. There we add a little bit of gas so that the tanks can stiffen up, which will help those clamp arms to open just beneath the payload fairing. If we will be getting some close-up views, you will be able to see that those clamp arms to open up. And there we go, we got the call out that the strong back retract process is now commenced. Now we will be able to see, I hope they will be providing us some close-up views.
And this includes RP1, a highly refined kerosene, and liquid oxygen chilled to over 300 degrees below 0 Fahrenheit.
Now, through those clouds, you can just make up those clamp arms that have retracted away from the
So
stage.
yes, well, you can see those clamp arms are open, and you can see that strong back started to recline, and this will the strong back will recline about 13 degrees away from the Falcon 9 since it's a Vandenberg flight. We are coming at T minus 3 minutes and 38 seconds. All systems are go for on-time liftoff. And while we are watching this live view of Falcon 9, a couple of important steps were completed. The spacecraft team switched to internal power a few minutes ago, and fueling of Falcon 9 first stage is finished, meaning all the RP-1 prop is now on board. We are still loading the liquid oxygen on both the first and second stages. So we will be listening in a couple of minutes for LOX load completion for both the stages.
When that cold oxygen gas hits the warmer outside air, it condenses into the clouds that you're seeing on screen. And this is the same principle as seeing your breath on a cold morning, just on a much bigger scale.
Now, the tanks are also...
Stage 1 LOX load is complete.
And there's that call.
There we go. We got the call out. Stage 1 LOX load is complete. And we are still loading the LOX on the second stage. And we will be waiting for the second stage LOX load completion call out. And that will be happening approximately like at just inside T minus 2 minutes mark. Now we are getting into 2.5 minutes. The range continues to be green, and weather, of course, as we can see there, has cooperated. Absolutely no issues from weather. We don't expect any weather conditions to develop in the last couple of minutes, and also any range issues, as yesterday we got a scrub for the range air traffic problems. Again, SpaceX mentioned in their webcast today that they will be having a backup opportunity tomorrow as well.
Stage 2 LOX load is complete.
And
There we go. We got the call out. Stage 2 LOX load is complete. All propellants are now on board the Falcon 9 with complete 1 million pounds of propellant. That's huge. Now we are now beginning to run down the pressure that was remaining in the tubing on the strong back. That's why you can see those clouds coming out there. It's absolutely good, and it's an healthy indicator of launch coming up. Next event, T minus 1 minute, we should hear the call out that the Falcon 9 flight computers are in startup and controlling the rocket for the remainder of the countdown.
The countdown will be fully autonomous. We should be hearing that call out in just about 8 seconds from now.
Falcon 9 is in startup.
And there's
Right on time, Falcon 9 flight computers on stage 1 and stage 2 are running the rocket through the last minute of count. Now let's listen to the go call out.
LD is go for launch.
Finally, we got the call out. SpaceX launch director giving go for the launch. We are coming up on T minus 32 seconds. All systems continue to remain go for the launch of Falcon 9 and Tracer's mission. So let's sit back and enjoy today's liftoff of Falcon 9.
T minus 15. T minus 10. 9, 8, 7, 6, 5, 4, 3, 2, 1. Ignition. And liftoff. Go SpaceX, go Tracers.
Vehicle is pitching downrange.
So we have a successful liftoff. Falcon 9 has cleared the tower, and we are getting some awesome ground tracking views of the Falcon 9 with the payload on board, reaching to its designated orbit. Now we got some good callouts. Power, telemetry, and propulsion is nominal.
Falcon 9 power and telemetry are nominal.
We are into the throttle bucket, We are now throttling down the 9 Meridian engines as we prepare for the period of maximum dynamic stress coming up.
Which is the point of maximum aerodynamic pressure.
Vehicle is supersonic.
So this call out, by that we mean that the Falcon 9 is exceeded Mach 1. Now Falcon 9 is faster than the speed of sound as we have gone supersonic. We got the call out from Max Q. We are through the period of maximum stress on the vehicle. We once again throttled the 9 Merlin engines back up to full power. Next up, we will have the MVAC engine chill, where we will start to chill down the MVAC engine on the second stage prior to its ignition just after stage separation. Just after that, we will be coming up to some series of events in rapid succession. The shutdown of main engine on first stage, that is main engine cutoff, also known as MECO, followed by stage separation. Then first stage will undergo a flip maneuver, followed by ignition of the second stage MVAC engine, also known as SES-1, that will boost the payload into low Earth orbit. So let's hear to those callouts. SpaceX is remarkably making their webcast to look beautiful.
Stage separation confirmed. MVAC startup.
Stage 1 boost back startup.
So there we go. We got all the callouts and we are getting some awesome views as we can see the first stage getting down back to the Earth. We got the callout from MECO, stage separation, MVAC ignition on the second stage, and the first stage boost back burn initiation. Now the first stage boost back burn will last for about 56 seconds long. Next, we are expecting for the payload separation.
Separation confirmed.
Excuse me, fairing separation. We got the confirmation for that. It's successful. So right now we are waiting for the call out for boost back shutdown on the first stage.
Stage 1 boost back shutdown.
There we go. We got the call out for stage 1 boost back shutdown. And we will be able to see slowly the on the left hand side of your screen the those titanium grid fins to slowly begin deploying. Now we are getting some awesome views from both the stages. Now the first stage is under the guidance of grid fins and gravity as it descends back to Earth. It will continue to rise towards apogee before descending back down towards the landing site, that is landing zone 4 at Vandenberg Space Force Base. Second stage, meanwhile, in middle of its about 6 minutes of burn and is on the way into the parking orbit. Now about the boost back burn, I will just like to highlight a simple information which we should be aware of, that the boost back burn is a burn which brings the instantaneous impact point, also known as IIP, to the vicinity to the launch site, ending the boost back burn, which we already had.
Of a single Falcon booster, which is absolutely phenomenal.
Now you might be asking that instantaneous impact point, what it is the location at which the vehicle would contact the ground if all thrust were to be instantly terminated. During a launch, the IIP must remain within the narrow corridor, and if the IIP, that is the instantaneous impact point, leaves the corridor, the vehicle's trajectory is very wrong and the flight termination systems will immediately activate it. But that's a rare case for SpaceX, that is absolutely no issues. Now, when we will be hearing the call out that stage 1 FT is being saved, it means the re-entry burn of stage 1 has been either initiated or accomplished, and hearing the stage 2 FT being saved means the second stage is up with the orbital insertion burn. Now we are expecting the stage 1 entry burn startup about 15 plus 4, 19 seconds from now. That will be the stage 1 entry burn startup.
In just about 10 seconds from now.
Well, Angry Bird, I guess that happened. We did had some landing failures previously.
Stage 1 entry burn startup.
And there's a confirmation. We just lit 3 of 9 Merlin 1D engines on the first stage. Now we are rapidly slowing down the vehicle, as you can see on the bottom left-hand side of your screen from the telemetry, as it enters the Earth's atmosphere. And this burn should last just around 17 seconds.
Stage 1 entry burn shutdown.
That's a short.
And there we go. There's a confirmation of the shutdown of the entry burn on the first stage.
Final burn.
Next call out we will be having for the stage 1 landing burn. That will be happening at T plus 7 minutes and 12 seconds. We are getting some awesome views. And there we go, the call out for stage 1 FTS being safe.
Re-entry burns, as well as the grid.
Now we are as I was mentioning, we are getting some awesome tracking views of the Falcon 9's first stage as it's reaching to its landing site. That is the landing zone 4 for today at Vandenberg Space Force Base.
Stage 1 transonic.
And we heard that call out. Stage 1 is now traveling slower than the speed of sound as it heads towards its landing zone. We are just less than 60 seconds away from the landing of the first stage.
Stage 1 landing burn.
There we go. Great views of that landing burn with center E9 engine now lit.
Terminal guidance.
With that, we are slowing down the vehicle furthermore very rapidly. Should be seeing those landing legs deploy any seconds now. So there we go. Stage 1 landing legs deployed.
Stage 2
And successful landing of the first stage. So we have successfully made the 459th landing of an orbital class Falcon 9 rocket, and this marks the 16th landing of this first stage booster supporting this mission.
Plus 8 minutes. And as a reminder,
Now
the MVAC engine
let's see whether SpaceX will be.
Nominal orbit insertion.
before we deploy all spacecraft.
And we got the call out for second stage MVAC shutdown, also known as SECO-1, and a nominal orbit insertion. So now let's see the SpaceX will be stretching the webcast or not for the payload deployments.
Plus 51 and 8-second mark. So we're going to take a pause here and leave you with some space jams, and we'll see you back here at T plus 49 minutes for second engine start 2.
So it's a confirmation from SpaceX's end that they will be showing us the payload deployment today, unlike the yesterday's O3M Power B mission. So right now we have ample of time to discuss about the payload. Now let me just tell you about the payload deployment. The payload deployment, before payload deployment at T plus 50 minutes and 44 seconds, the second stage MVAC engine will reignite for the second time in today's flight for a short 3 seconds of burn, that is also known as SES2, and turning it off at T plus 50 minutes and 47 seconds, that is SECO2. After less than 4 minutes following SECO2, satellite deployment will begin at approximately T plus 54 minutes and 30 seconds into the flight for the first set of payloads deployment, beginning with the Bard satellite, followed by the real satellite at T plus 54 minutes and 50 seconds. Today's payload deployment will be happening in 2 sets. That is the first set, which I already mentioned, with the beginning with the Bard and real. And following that, the second stage will again be about be in a course phase about for a 10 to 11 minutes, where the second stage will again reignite for the third time in today's flight and having a just quick 1 second of burn, and then we'll be having the SECO3, that is the second stage engine cutoff, for the third time in today's flight. Following that, again back, we will be having 25 minutes approximately of course phase, and then at T plus 1 hour 30 minutes and 7 seconds we will have the second stage engine cutoff, engine startup, that is the SES1, And that burn will again also will last for 1 second with the second stage followed by the second stage engine cutoff, that is the SECO 4. So that's today the second stage will be relighting for the 4 times in today's flight, which we will be seeing, and actually it will be 5 times counting the deorbit burn. Now again the second batch of the payload deployment will begin at T plus 1 hour 34 minutes and 26 seconds with the first tracer satellite deployment. After that first tracer satellite deploys, about 6 minutes or so, we will have the second tracer satellite deployment at T plus 1 hour 40 minutes and 41 seconds. Next up will be the EPIC Athena deployment at T plus 1 hour 44 minutes and 46 seconds. And following that, we will have the LIDE deployment at 1 hour 45 minutes and 6 seconds into the flight. And finally, we will have the last payload to deploy in the second batch of the payload deployment sequence with the Skycraft 4 deployment, which will be happening at T plus 1 hour 45 minutes and 26 seconds. So that's all about the post-launch timeline and the payload deployment. Once again, just a reminder, today's launch marks SpaceX's 518th successful mission, with landing marking their 478th success. So we are having some ample of time right now. So let me just quickly set up the stream for you guys so that we can have our discussions for the payloads on board today. Please give me a couple of seconds. I'm just making them on my streaming software so that we can discuss about them in more details. Now let's dive into the technical nitty-gritty of the SpaceX Tracers mission. This mission is a fascinating rideshare headlined by NASA's Tracers mission, but packed with other payloads, as we know, and they are pushing the boundaries of space science and technology. We are talking about SEOP's EPIC Athena, Skycraft's Skycraft 4, Mavericks Space Systems Real, Tyvak's LIDE, and York's Space Systems Bard. So right now I'm going to break down each payloads with detailed technical specification, including who built them, who is operating them, and the programs that they fall under. So first up, the star of the show, NASA's Tracers, also known as Tandem Reconnection and Cusp Electrodynamics Reconnaissance Satellite. This mission is all about studying the magnetic reconnection, where Sun's magnetic field interacts with Earth's magnetosphere, causing field lines to snap and reconnect, releasing high amount of energy that drives space weather events like those beautiful auroras on our northern poles and south poles, or satellite disrupting geomagnetic storms, and it can even disrupt the power grids here on Earth. Now, tracers will focus on the polar curves, funnel-shaped region near the north and south poles, where solar wind particles sneaks into Earth's atmosphere. Now, let's talk about the technical specifications of the satellite. Well, just a second, let me make it on loop. So tracers consist of 2 identical satellites, also denoted as T1 and T2. Each builds on please excuse me, I was just a little bit choking. Now, these 2 identical tracer satellites are built on Millennium Space Systems Altair core bus platform. Now let me just pronounce this for that you can more understand in a right way. That Altair, I said it pronounced at ALTAIR, core bus platform. Now each satellite has a launch mass not exceeding 200 kilograms and is passively spin stabilized at a normal rate of 10 rpm revolution per minute for magnetic and electrostatic cleanliness. They operate in a sun-synchronous. They will be operating in a sun-synchronous orbit at approximately 590 kilometers, which is equivalent to 367 miles altitude, with a separation of 75 to 900 kilograms, traveling each other by 10 seconds to up to 120 seconds. Now, each satellite carries tracer satellite carries 6 instruments, namely analyzer. Firstly, the analyzer for cusp electrons, also known as ACE in short, which is an electrostatic analyzer from Southwest Research Institute, measuring electrons from 40 electrovolt to 10 kilo electrovolt. Next instrument on board the tracers is the analyzer for cusp ion, also known as ACI in short, which is an electrostatic analyzer from Southwest Research Institute, which measures ions from 50 electrovolt to 10 kilo electrovolt. Next up is the DC magnetometer, also known as MAG in short, which is a flux gate magnetometer from UCLA, measuring background magnetic fields up to 5 Hertz. The next instrument on board the tracers is the search coil magnetometer, also known as MSC in short, which is a 3-axis magnetic search coil from the University of Iowa, measuring the AC magnetic fields, that is the alternating current magnetic fields from 2 Hertz to 1 kilohertz. The last two instruments on the tracer satellite are namely the electric field instrument, that is EFI in short. It is a 2-axis electric field experiment from UC Berkeley, measuring fields from 1 Hertz to 1 kilohertz. And lastly, the MAGIC, it's the short form of magnetometers for innovation and capabilities, which is a technology demonstration from the University of Iowa testing prototype magnetic fields instruments. This satellite uses a high gain antenna for data downlink and are powered by solar panels with a mission duration of at least 12 months. Tracer satellites are manufactured by Millennium Space Systems, which is a Boeing subsidiary who build the satellites with instruments developed by the University of Iowa, Southwest Research Institute, UCLA, and UC Berkeley. Tracer satellites will be operated by University of Iowa, led by Principal Investigator David Miles, who manages the mission with the oversight from NASA's Heliophysics Explorers Program Office at Goddard Space Flight Center. Now, TRACERS is a part of NASA's Small Explorers Program, which stands for SMEX in short, which supports cost-capped, high-impact heliophysics missions. The mission has a total cost of approximately $170 million, and which was selected back in 2019 alongside the recent launch of NASA, which you might be remembering about the Punch mission. Now, the objective of the NASA's TRACERS mission, as I discussed earlier also, once again I'm repeating, it's to study the magnetic reconnection in the polar cusp, capturing thousands of dayside reconnection events to understand how solar wind's energy transfers from Earth's magnetosphere, aiding space weather prediction and technology predictions. So that's all about the tracers. we are left with 6 more payloads to discuss. Let's just see how much time it is right now into the flight. It's 21 minutes. We will be having the next event at approximately 54 minutes, so we have ample of time. Now, next up, let's discuss about the next payload on board today. Well, Angry Bird, yes, it took me whole night to make this all information to gather together, to find the images so that you can have everyone can have a good overview that how the satellite looks like. Although for some of the payloads, I couldn't manage to have the images or anything or any videos, but I guess that is enough to, from my side, my opinion. Of course, it's not enough, no matter how much information you will be getting. It's less for space science, but I think that this will give a rough idea to everyone about the payload. Well, I know it's kind of a rideshare mission. It will take a little bit longer what to do. So you can sleep. Meanwhile, just open your eyes for the payload deployments if you are interested in about that. And I'm referring to Angry Bird. So let's move on with the payload deployment, payload details discussion we are into. So next we got the Athena EPIC, or the Economical Payload Integration Cost, which stands for EPIC in short, a small sat designed to shake up how we deploy remote sensing instruments. This is about making space missions faster, cheaper, and more flexible by using modular sensor craft architecture that allows multiple payloads to share resources. Now, Athena EPIC is a approximately 110 kilogram small sat built by NovaWorks Hyper Integrated Satellite, which is also known as HiSat platform, a building block style design that supports scalable resource sharing spacecraft. The satellite carries a Department of Defense experiment to test this innovative architecture, which includes shared power communication and attitude control system. It will be operating in a sun-synchronous orbit as well, like all other payloads, at approximately 590 kilometers, with a mission duration focused on demonstrating rapid response capabilities within a 7 months deployment timeline. The spacecraft features a compact modular design optimized for cost efficiency and adaptability to various remote sensing payloads. NovaWorks, a space startup, developed the spacecraft with NASA's Langley Research Center leading the design and integration. The Athena EPIC payload will be operated by CEOPS, which provides the mission management and integration services with oversight from NASA, NOAA, that is NOAA, and the US Space Force's Space System Command. The Department of Defense Space Test Program manages the overall experiment. Now, Athena EPIC is a part of NASA's Venture Class Acquisition of Dedicated and Rideshare, also known as VADR program, which facilitates affordable launches for small satellites. Worth mentioning, it is also the 5th of 6 spacecraft under United States Space Force's Rideshare 2024 Blaze contract with CEOPS. Now, to conclude with the payload details for the Athena EPIC, let's jump into the objective of this payload, which is to demonstrate a configurable, cost-effective platform for deploying remote sensing instruments, fostering collaboration across NASA, the Space Force and paving the way for future rapid response missions. So now let's move on to the next payload. So the next payload we have on board is the REAL, which stands for relativistic electron atmospheric loss, which is a CubeSat and is a small but mighty mission focused on Earth's Van Allen belt radiation belts, where high energy particles can damage satellite electronics. Now, REAL aims to understand how these particles are scattered into the atmosphere and where they dissipate. Now, coming to the technical specifications of the REAL satellite, as I mentioned, REAL is a CubeSat, likely of 6 units based on typical NASA CubeSat design, with a mass of approximately 10 to 12 kilograms. It carries an instrument sensitive to high energy protons and electrons, designed to measure particle fluxes and their scattering into the atmosphere. The satellite is built on technology from Montana State's University's IT Spins CubeSat with upgrades for enhanced particle detection. It operates in a Sun-synchronous orbit at 590 kilometers, similar to other payloads, and is powered by solar panels and equipped with basic attitude control systems for orientation. The mission duration is expected to be several months, although it is not specified particularly in a public domain, so we can't say the specific mission duration, but it will be lasting for several months to collect sufficient data on radiation belt dynamics. Now, REAL is the Dartmouth College developed the REAL payload under NASA's CubeSat launch initiative, with Maverick Space Systems providing integration and deployment support. Dartmouth College will be also operating the CubeSat with data analysis supported by NASA. Now, about the program in which REAL falls is similar to the previous payload, which is a part of NASA's VADR program, which supports rideshare launches for small sats and is also funded through NASA's CubeSat launch initiative, marking New Hampshire's first CubeSat launch under this initiative. The objective of the REAL payload or the CubeSat is to characterize the loss of relativistic electrons from the Van Allen radiation belts, informing strategies to mitigate radiation risk to satellites and critical ground systems. So that's all about the REAL payload. Let's move on to the next one. So next we have the BARD, also known as Polylingual Experimental Terminal, known as PExT, PExT in short, which is a NASA-funded technology demonstration to improve spacecraft communication by enabling seamless network switching. Coming to the technical specifications for this payload, Bard is a small satellite. The exact size is unspecified, but it is likely to be a CubeSat or small sat under 100 kilograms. It is being developed by York Space Systems, and it carries an advanced communication terminal operating across a wide Ka band frequency range that is from 17.7 GHz to 31 GHz, which allows it to interface with multiple commercial and government satellite relay networks. The terminal supports real-time network roaming, similar to our cell phones network switching, and the satellite operates in a sun-synchronous orbit at 590 kilometers, powered by solar panels, with a mission duration of approximately 6 to 9 months for the initial demonstration. The total life cycle cost is $20 million over 5 years. York Space System developed the Bard satellite with contributions from Johns Hopkins University Applied Physics Laboratory. NASA Space Communications and Navigation Program, also known as SCAN in short, will be managing the mission, or you can say will be operating the mission, with Applied Physics Laboratory supporting the operations. Bard is also a part of NASA's VADR program, leveraging rideshare opportunities to test innovative technologies. Now, objective of the Bard satellite is to demonstrate a polylingual communication terminal that enables spacecraft to roam between networks, enhancing connectivity for future missions in science and exploration. And right now on your screen, you can see what I mean by the switching of networks, or you can say here it will be act as a relay, satellite relay network. The Bard will be able to connect with satellites on low Earth orbit, medium Earth orbit, as well as a geostationary orbit. So this will make the Bard to have its unique capability to communicate with all the satellites in different orbits with different bands that I mentioned, that is the Ka band frequency, which Bard is having a wide range that is from 17.7 gigahertz to 31 gigahertz, so that it can cover all the different commercial and government satellites on different orbits and to communicate with them. So that's the objective for the Bard satellite. Now let's once again check how much time is left for the next event. We are approximately 20 minutes away from that. So let's just quickly get done with the next payload. How many we covered? We covered up until now 4 payloads. So more 3 to go. No, we actually covered 5 of them, so more 2 to go, thankfully. Now, next we have the direct access live demonstration, which is also known as LIDE, which is a European Space Agency mission testing advanced satellite communication technology to support 5G connectivity from space. It is a step towards global broadband access, especially in unreserved areas. The technical specifications of this satellite is that it is a 12-unit CubeSat with a mass of approximately 20 to 25 kilograms, built by Taviak International, which is a part of Terran Orbital, a Lockheed Martin company. It carries a bidirectional K-band and Ka-band radio frequency transponder compliant with the 3GPP non-terrestrial network, also known as NTN in short, standards, designed for direct access tests with ground terminals, which is a gateway and an end user terminal. The satellite features an active attitude determination and control system to maintain precise orientation for optimal signal strength, and it will be operating in similar to other payloads in a sun-synchronous orbit at around 590 kilometers with solar panels and batteries providing power for a mission duration of several months. Once again, the specific duration of this mission is undisclosed, so we can provide that information to you guys. Sincere apologies for that. Light is built by Tavyak International, who developed and built the CubeSat, and it will be operated by European Space Agency's Connectivity and Secure Communication Office, which will be managing and operating this mission. Light is an European Space Agency mission not tied up to a NASA program, but it leverages NASA's VADR contract for launch access as a right-ship payload on Tracer's mission. Now, objective of the Light satellite is to validate the K-band and Ka-band transponder technology for 5G broadband directly from space, supporting European Space Agency's REMI mission as well, and enabling high-speed connectivity in rural and suburban areas. Now, I guess we are just left with one payload to discuss about. Yep, we are at the end of the payload discussion for today. Oh, sorry, excuse me. It's on loop for this slide. Well, unfortunately for this payload, we couldn't manage and couldn't find any of the payload, actual payload image, so that you can have a better perspective that how the payload looks like. Although this is a rendered or you can say an animated conceptual picture for the payload. We did extensive research, but unfortunately we got only this image to come up with. So this is all about the now spacecraft 4, which is a set of 5 Australian satellites aimed at leveraging air traffic management, that is the ATM in short, from space. This is about bringing real-time communication and tracking to aviation, especially in remote areas like oceans where ground-based system falls short. Skycraft 4 consists of 5 satellites, including a deployment tug, that is the Skycraft 1, which will be enclosing the 4 other spacecrafts, and which is having a total mass of approximately 260 kilograms. The satellite uses the VHF frequencies and automatic dependent surveillance broadcast, that is ADS-B in short, technology for aircraft tracking and communication. The deployment tug separates from the Falcon 9, will separate from Falcon 9's upper stage about 1 hour and 45 minutes, which will be after the liftoff, which will be the last payload today getting deployed in the second deployment sequence, which will be releasing the other 4 satellites into a sun-synchronous orbit at around 590 kilometers altitude. Each satellite is equipped with communication payloads for real-time data exchange between air traffic controllers and pilots, and with power provided by solar panels and onboard batteries. The design prioritizes high reliability and low latency for air traffic management applications. Skycraft is an Australian aerospace company developed and built the satellites. These satellites will be operated by Skycraft in collaboration with Air Services Australia, which will be operating the constellation to test regulatory framework for space-based air traffic management. Skycraft 4 is a commercial payload not tied to any specific NASA program, but it leverages SpaceX's rideshare program for launch access, facilitated by, again, NASA's VADR contract with SpaceX. Now, objective of the Skycraft 4 payload is to validate space-based air traffic management services, enabling global air traffic tracking and communication, which will be enhancing aviation safety and efficiency and supporting the deployment of a larger Skycraft constellation in near future. So that's all about the payload discussion and the technicalities of all the payloads. I hope this provided you a little bit of more insights. Now we are approximately, let me see the timeline. So we are approximately 6 minutes, approximately 6 minutes for the next event. That will be the second stage MVAC engine reignition for the second time in today's flight for a short 3 seconds of burn, that is SES2, and turning it off at T plus 50 minutes and 47 seconds, that is SECO2. After less than 4 minutes or so following SECO2, satellite deployment will begin at approximately T plus 54 minutes and 30 seconds into the flight for the first set of payloads, beginning with Bard satellites, followed by a real satellite at T plus 54 minutes and 50 seconds. So I will be joining you guys in a while. Meanwhile, you guys sit back and enjoy the payload deployment sequence. Once again, those of who are still hanging with us, just a kind request. If you think we are adding value to your viewing experience and adding a little bit of information more than what any other streams do, please consider providing a like to the stream. It really helps the YouTube algorithm to push this stream to more space enthusiasts like you joining us right now. So you guys sit back and wait for the payload deployment, which will be beginning at T plus 54 minutes and 30 seconds into the flight, with the first payload, the Bard satellite, be getting deployed. And once again, just a reminder, today's payload deployment will be in 2 sets. The first set, which I already mentioned, consists of Bard and real satellites. The second set of the payload deployment consists of the twin tracer satellite, EPIC Athena, Light, and Spacecraft 4, being the last one to be getting deployed at T plus 1 minute, 45 minutes, and 26 seconds. So I will take a break from you guys now. I will be joining you in a while with any updates. Meanwhile, sit back and enjoy the stream.
coverage of the Tracers mission. If you're just joining us, we had an on-time liftoff at 11:13 a.m. Pacific time, followed by successful ascent, stage separation, entry, and landing of the Falcon 9 first stage, as well as the completion of the first burn of the second stage MVAC engine about 8 minutes after launch. Now everything with the rocket and payload looks healthy, and the vehicle is currently flying over the Indian Ocean near Madagascar. Now, as a reminder, we're planning to have 4 separate burns of the MVAC engine on the Falcon 9 second stage before all payloads are deployed. And we're now approaching the second burn to reach the orbit needed to deploy the first spacecraft. Now, that burn will be pretty brief and will last just about 3 seconds. We should be hearing a call out for that burn in just under a minute from now.
Hi there, everyone. I'm me, Dipto, from AstroYonder team, joining you back.
Orbit insertion.
We just saw the
And there you heard it,
second stage,
orbital insertion.
second stage engine startup, that is SES-1, lasting for a short 3 seconds of burn and turning it off at T plus 50 minutes and 47 seconds, that is SECO 2. Now we are just less than 4 minutes following the SECO 2, which already happened. We got the visual confirmation for that. The satellite deployment will begin at approximately T plus 54 minutes and 30 seconds into the flight for the first set of payload deployment sequence, beginning with the Bard satellite, followed by real satellite at T plus 54 minutes and 50 seconds. We are getting some awesome views of the payload on board the second stage, and it got off. Now we are approximately 3 minutes 30 seconds away from the first set of payload to be getting deployed. That is first with the Bard, followed by real satellite. Hopefully we will be getting some awesome views of them. Now, just 2 minutes, less than 2 minutes from now, we will be hearing the call out for the payload deployment for the Bard satellite and real satellite. And following the real satellite deployment, it will mark the first set of payload deployment sequence to an end. And following that, we will get into about 11 minutes of course phase, where we will have the third time ignition of the second stage engine and cutoff, followed by fourth time. And then finally, we will be having the Tracer satellite deployment, which will mark the second phase of the payload deployment sequence for today's mission. Now let's listen closely to the callouts for the payload deployment.
York Space Systems Bard separation confirmed.
And great call out there for payload deployment of the Bard mission. We're now waiting for confirmation of the real payload.
Real separation confirmed.
And there we go. We got the call outs for both Bard and real satellites.
So we'll see you
that mark the ending of first payload deployment sequence for today's payload. Now we will be coming back to the second payload deployment sequence that will begin at T plus 1 hour 34 minutes and 26 seconds, starting with the first tracer satellite deployment, followed by the second one for the tracers. Then we will have the EPIC Athena deployment, followed by LIDE, and lastly by the Skycraft 4 deployment. Now, before this all second payload deployment sequence where the tracer satellite, EPIC Athena, LIDE, and spacecraft will be getting deployed, we will have 2 more times the ignition and cutoff of the second stage MVAC engine, and that will mark finally the 4 times the second stage MVAC engine ignition and cutoff in today's flight. So once again, I will take a break from you guys. Meanwhile, you guys enjoy some music and enjoy the awesome views we are getting from second stage. I'll be joining you in a while. So sit back and enjoy the payload deployments coming up next. Hi there, it's me Dipto from AstroYonder team. We are getting close to the next milestone in today's flight. That will be the fourth time the ignition of the second stage engine in today's flight, marking the SES-4. That burn will just last around 1 second, marking SCO-4. That is the fourth time the second stage engine will cut off. Now followed that we will be having approximately 4.5 minutes of another course phase, and then we will be having the star of the show to be getting deployed today. That is the Tracers satellite, the first Tracer satellite to deploy at T plus 1 hour, 34 minutes and 26 seconds. Now, as I discussed previously, everything in details with technical details as well for all the payloads. Now, just to recap, we had a on-time liftoff at 11:13 a.m. Pacific time. Then everything went as planned. We are now up, reached to the milestone up to third time the second stage engine ignited. That is SES-3, and following that we had SECO-3 at T plus 1 hour, 5 minutes and 41 seconds. Now we are waiting for the second stage payload deployment sequence, which will begin with the first Tracer satellite deployment, followed by the second Tracer satellite deployment, and then we will have the rest of the 3 payloads remaining in today's payload on board the second stage right now. That is the EPIC Athena, LIDE and Skycraft 4 deployment. And with that Skycraft 4 deployment, it will mark the successful payload deployment, completion of the successful payload deployment sequence 2, and we will be wrapping up our coverage. So you can say we are just 15 minutes away from wrapping up the coverage, and right now we are just 1 minute, yes, approximately 1 minute away from the less than 30 seconds, not 1 minute even, for the fourth time second stage engine will ignite, marking SES-4 with a burn of 1 second, and then marking the SECO-4. Our first payload, as I mentioned, will be the Tracers. The objective of the Tracer satellite, as mentioned and discussed everything earlier, but once again I'm repeating, is to study the magnetic reconnection in the polar cusp region, capturing thousands of dayside reconnection events to understand how solar wind energy transfers into Earth's magnetosphere, aiding space weather predictions and technology protections. And there you go. Just a quick 1 second of burn. We got the visual confirmation for the second stage engine ignition, marking the SES-4, and following that we got the visual confirmation for second stage MVAC engine cutoff, SECO-4. And we got the caller for nominal orbit insertion. Now we will be waiting for the next phase of payload deployment. That will be the second phase, with the first Tracer satellite deploying at T plus 1 hour, 34 minutes and 26 seconds approximately. So we are just 3 minutes away from that. This Tracer's mission features 2 identical satellites, also denoted as T1 and T2. each equipped with 6 instruments to measure electric and magnetic fields, as well as particles involved in reconnection events. These instruments were developed by a team including the University of Iowa, Southwest Research Institute, UCLA, and UC Berkeley. The satellites are built by Millennium Space Systems, which is a Boeing subsidiary and operated by the University of Iowa, led by principal investigator David Miles, with oversight from NASA's Heliophysics Explorers Program Office at Goddard Space Flight Center. We are getting some awesome views out there from the second stage. Now, following the successful deployment of both the twin satellites for tracers, we will have the EPIC Athena to getting deployed. The objective of EPIC is to demonstrate a configurable, cost-effective platform for deploying remote sensing instruments, fostering collaboration across NASA, NOAA, that is NOAA, and the Space Force, which will be paving the way for future rapid response missions. Then we will have the LIGHT satellite to deploy. The objective of LIGHT is to validate K-band and Ka-band transponder technology for 5G broadband from space, supporting European Space Agency's REMI mission and enabling high-speed connectivity in rural and suburban areas. Now we are getting close to the payload deployment for the first tracer satellite, so let's listen in to the caller. Hopefully we will get the views of the payload deployment as well. Once again, those who are still there with us, a heartfelt gratitude for showing your such patience and supporting us.
Tracers SV2 separation confirmed.
And there we have it, successful deployment of the first of 2 Tracers satellites, and a beautiful view on screen there. Our next deployment will be the second Tracers satellite in about 4 minutes. So we're going to take a quick break. We'll be right back for our...
So we got the first Tracers satellite to get deployed. Next, as we just heard, we will be having the second Tracer satellite to deploy approximately less than 4 minutes from now. The Tracer satellite is a set of twin satellites. As I said, they are identical satellites, also denoted as T1 and T2. And this tandem setup allows them to capture sequential data as they pass through the northern polar cusps multiple times daily, giving scientists a dynamic view of how reconnection unfolds. Each satellite has a launch mass not exceeding 200 kg and is passively spin stabilized at a nominal rate of 10 RPM for magnetic and electrostatic cleanliness. These both satellites will operate in a Sun-synchronous orbit at approximately 590 kilometers altitude, with a separation of 75 to 900 kilometers, trailing each other by 10 seconds to 120 seconds. And each satellite carries 6 instruments, as I mentioned before, These tracer satellites are powered by solar panels, and this mission is expected to last a duration of at least 12 months. Tracers falls under NASA's Small Explorers Program, also known as SMEX in short, which funds high-impact, cost-effective heliophysics missions. The goal is to deepen our understanding of space weather, protecting everything from satellites to astronauts by predicting and mitigating solar-driven disruption. About a minute from now, we will be getting the call out for second tracer satellite getting deployed. Now, finally, today's payload deployment, the second phase of payload deployment sequence will conclude with the Skycraft 4, which objective is to validate space-based air traffic management services, enabling global aircraft tracking and communication for Australia, as well as worldwide, enhancing aviation safety and efficiency. And also it will be supporting the development of a larger Skycraft constellation in future. Less than 30 seconds from now, we will be getting the call out for second tracer satellite getting deployed. So let's listen into the call outs carefully.
Tracers SV1 separation confirmed.
And there we go. We got the call out for successful deployment of both the tracers satellite with the recent one, the second tracer satellite deployment. Now, next up, about 4 minutes from now, we will have 4.5 minutes from now, we will have the EPIC Athena, LIDE, and Skycraft payload. Now, just a quick fun fact that about a tracer satellite. This tracer satellite will investigate about the magnetic reconnection in the polar curves region, as I mentioned before, and this will work with in collaboration with other heliophysics science mission launched recently, being the NASA's Punch mission, and also previously with the EASY mission from NASA. So together they will give a broader picture and a clear understanding of the magnetic reconnection, and also to understand the space weather. And as we all know, the space weather is mainly driven and affected by the sun. So as they all falls into the category of heliophysics science mission, they will be studying more about the sun, its solar flares, and its other activities as well. Now just 3 more satellites in today's payload are left with Athena EPIC, Light, and Skycraft 4. But just we are waiting for this final phase. It is taking a little bit time, but just when we will be having the EPIC Athena to getting deployed, followed by that we will have approximately 15 or 20 seconds or so, the Light satellite will deploy, and following 20 seconds or something, we will have the final deployment of the Skycraft 4, which will be the Skycraft 4 tug housing the 4 other satellites will be getting deployed, and that will be marking the final payload deployment and the conclusion of the payload deployment sequence for today's mission launch. So those 3 will be getting deployed in quick rapid succession. They won't be taking much time. Just we have to wait for this final phase to begin. Approximately 2 minutes from now. And we got the view already. The EPIC Athena satellites getting deployed.
And welcome back to our live.
So I guess SpaceX messed up. They didn't understood. So EPIC Athena getting deployed, and we got that Light satellite deployment.
And confirmation
now
of the TIVAC payload as well.
The last satellite is left is the Skycraft 4 deployment. That will bring us to the conclusion of today's payload deployment sequence completion.
Skycraft 4, Skycraft 5 ATM spacecraft, separation confirmed.
So there we have it. So all the satellites being deployed successfully. Now that was the last Skycraft 4 deployment. So with that, we will wrap up our coverage. Now, just a reminder, today's launch marks SpaceX's 518th successful mission, with landing marking their 478th success. So with that, we will wrap up our coverage for now. But before wrapping up, want to thank you for wherever you are watching our live launch coverage. Thanks for those who stayed with us until now, till the end of the webcast. Really, to us, I must admire your patience. It is impossible to do this broadcast without you and your encouragement. So thank you for your continued support of what we do here at AstroYonder. Be sure to check out the upcoming launch coverages on our channel, and also check out our social media handle on X for the latest happenings in space industry and updates on upcoming launches. I guess the link got posted on the chat section. So we appreciate everyone joining us for today's launch. Wishing you a nice week ahead. Once again, thanks for watching. This is AstroYonder Live and me, Dipto, signing off for now, and we will see you soon.